My name is Joe Kopaz.
And I'm Justin Kopaz.
And this is the J&J Monorail. This is the J&J Monorail. As you can see, the monorail is approaching the station right now. Right here it hits the magnet. There's a magnet underneath that triggers the magnet detector inside. It enables the regenerative braking, and the train waits at the station for 2 seconds and starts up again. The board is simple plywood that was reinforced with 2x4s. These are aluminum studs with 2x2 posts that are reinforcing them, holding them up. The train has a light detector inside which lets it know when to turn on and off the lights, so as it goes through this tunnel, it'll enable its lights. As you can see, the lights in the train are on right now. This mountain was constructed from wire mesh covered with paper mache. The train station was built from simple balsa wood. You can see that there are cross braces underneath here that are held up by the supports. The track construction was a little bit tricky. We had to widen the track here. That way the train wouldn't topple off due to the small scale. We weren't able to put in a mechanism that would stabilize it. The track corners had been duct taped to make the correct sizing. And the corner is 9 inches in radius and has a 20-degree angle to allow the train to make.
We have a bank of resistors connected to ground. This limits the current to our LEDs inside of the train. We also have a photoresistor in series with a 5K ohm resistor. We read the voltage division between them using an analog pin on the Arduino. We also read an analog signal coming from the Hall effect detector. When it detects a magnetic field, it changes the output on the analog signal. We have a MOSFET in charge of controlling the driving. We have another one for regenerative braking, and we have another one to protect the battery from overcharging. We use a 2.1 millimeter plug to power the Arduino, and this is in series with a switch coming from one of our power sources. The other power source is a rechargeable battery, and this goes directly into the MOSFET. When the Arduino signals it, this battery powers on the wheel.
During the manufacturing of the train, we used a 3/4 inch end mill coming in, which left 0.3 inches of material. We then came in with a 3/4 inch ball nose end mill to refine the edges and really complete it. There were other setups coming in from the side to do the windows, and again from the front to do the LED holes and the window here. During the bottom setup, we drilled pinholes to allow the train to sit on top nicely. These are 1/8 inch finely ground steel pins. Inside, we've taken out as much material as we could in order to limit the weight and to lower the center of gravity of the entire train,
you can see
allowing
in this horrible
it to stay
phone
on the
video,
track.
the CNC is cutting around the outside of the train with the ball nose end mill.